Okay, so let's look at some different problems that we could make from using conditional probability. So our first example here says that at the fictional George Washington High School, after-school activities can be classified into 3 types, either athletics, fine arts, or other. The following table gives the number of students participating in each of these types of categories as by different grades. So let's say just a regular probability, and how they differ from each other. Well, if we said the probability that we had someone in, of someone in an athletic club, well, we need to take all of the people in the athletic club, so 600, and divide them by the total number of students, which is going to be 1,600. Okay, so that's adding everybody up together. So this probability ends up being 3/8. So 3 out of every 8 students are going to be participating in athletics, which is or those participating in after-school activities are participating in athletics. But let's say that we now said the probability that they participate in athletics, given that they are a 10th grader. So now what we have to do is we have to look at the intersection of the 2 columns in order to figure out what we're looking for. So this is our given, which in a sense is our denominator. And so what we do here is we say, okay, well, our denominator is now our 10th grade group. So, oops, that's 12th grade. Our 10th grade group, well, that totals 390 people. And we're going to divide that by the chance that they're in athletics. So we look at this column. Well, the chance that they're in athletics and in 10th grade is the intersection of these 2 things. So that is going to be 160. So when we go and figure out what this probability is here, 16 over 39, can I even reduce that? No. So we just get 16/39. And so this is, it's pretty similar probability overall, pretty close to the probability of being athletics, but this is more specific to the 10th graders participating. So instead of looking at the whole, you now have to look at your numerator is the intersection of 2 events, and your denominator is just the likelihood of whatever is given happening. So that's why we've changed, instead of looking at all 1,600 to just looking at 390. So this is a good way and a very quick way of determining conditional probability. So let's look at another one. All right, so a GFI, or what they call a ground fault interrupt, switch turns off power to a system in the event of an electrical malfunction. A spa manufacturer currently has 25 spas in stock, each equipped with a single GFI switch. 2 different companies supply the switches, and some of the switches are defective, as summarized in the following table. So why they would have this table and not fix them, no one knows, but it doesn't matter. We have a table of stuff. So if we just look at, something like the probability of being defective, the probability that that you pick a random spa out of the 25 total, and it is defective, well, that is going to be the chance that it's defective, which is this column. So we're looking at the total. So that's 7 items over the total, which is all items, which is going to be 25. So this is 7/25. You can't reduce it. You can leave it just like it is. So what about if I said the probability that it is defective given that it comes from company 2? So now what I have to do, again, this is our given, which means it is in a sense our denominator. So when we look at this, company 2 is our denominator. So we have 10 total options for company 2. Well, and we want to know the chance that it's defective. So we look at our defective column, and we only look at the intersection of these two events. So we get 2. And so our probability overall is 1 in 5. Which this is actually lower than our percent of defective. That kind of tells us that company 2 is obviously a little bit better than company 1 when it comes to it's being defective. And we can look back at the data and kind of determine that a little bit better.